Hi guys, on this video we will be solving another two problems in basics of thermodynamics, no? And we will be showing you kung paano gamitin yung mga natutunan natin in our lecture video about enthalpy. So, when we presented that video about enthalpy, nag-solve na rin tayo ng mga sample problems, no? But this time we will be solving another two problems. So, medyo mas mag-advance lang tayo ng konti compared sa mga na-solve natin previously. So, dalawang problem lang naman to, but I guess with this problem, you will have an idea kung paano natin i-apply yung mga natutunan natin in enthalpy and also yung natutunan natin about specific heat capacity, no? Because as you can see, we will be applying that here, no? We will be calculating for Cp and K, which is na-discuss natin sa ating previous video in specific heat capacity, no? So, this will be an interesting problem, no? So, kaya I would suggest na panoorin din niyo itong video na to and it will help you in your school, no? Sa inyong pag-aaral and your exam. So, hindi na natin patatagalin pa. Let us now jump to our discussion. Okay, so let us start with problem number 1. For low pressure oxygen in a temperature range of 300 to 2750 Kelvin, the experimentally determined specific heat at constant pressure is Cp, which is equal to 1.507 minus 16.77 over the square root of T plus 111.1 over T, which is in kilojoules per kilogram per Kelvin. Where T is in degree Kelvin, calculate the change of enthalpy per kilogram of oxygen when heated from 400 to 1000 Kelvin. Alright, so we have our equation for our change in enthalpy, which is the integral of Cp dt, right? And on this case, we have our temperature operating from 400 to 1000 Kelvin, okay? So we have from 400 to 1000 Kelvin. Well, of course, guys, we know that our delta H is equal to mCp dt, no? But as you can see in our Cp, no, our specific heat capacity, we can see that it is expressed in kilojoules per kilogram per Kelvin, no? So this will be already operating per kilogram of our gas in this case, no? Now, we have here a low pressure oxygen, no? So we could assume that this low pressure oxygen is behaving like an ideal gas. Okay, so now we have our equation of our Cp in here. So we could substitute that here because our Cp is expressed relative to temperature, no? So let us substitute that dito sa ating equation, okay? So we have delta H, which is equal to the integral of Cp, and our Cp is 1.507 minus 16.77 over the square root of T plus 111.1 over T, and we have dt, no? So we'll have to apply the properties of integral, no? So we can distribute that here on every terms ng ating equation here. So our delta H will be equal to the integral, okay, of 1.507 dt minus 16.77 the integral of dt over the square root of T. Okay, this is also from 400 to 1000. Then we have plus 111.1 the integral of dt over T from 400 to 1000. Okay, now let us work on our equation so that we could solve it by integral calculus, no? So we have delta H is equal to 400 to 1000, 1.507 dt minus 16.77, the integral of t to the negative 1/2 dt. Okay, so we just simplified dito to, no? We converted first itong ating radical na nasa denominator, no? We converted that to exponent, which is t to the 1/2. But since it is in the denominator, we moved it to our numerator, so we will have a negative sign sa ating exponent, ano? Then, in here we have 111.1, our integral dt over t. Okay, so now we can solve for our problem in here, no? So we have our delta H, which is equal to, so what is the integral of 1.507 dt? So this will be equal to 1.507 times t, right? And this is from 400 to 1000. Then we have minus 16.77, the integral of t to the negative 1/2 dt, which is t to the 1/2 over 1/2. Okay, and this is also from 400 to 1000. Then we have plus 111.1, the integral of dt over t, which is ln t, from 400 to 1000. Okay, so now let us solve for this. We have delta H, which is equal to 1.507 times 1000 minus 400, then minus 16.77 times 2, because we have denominator here na 2, no? So times 2, and then we have square root of t. So we have the square root of 1000 minus the square root of 400. Okay, then we have plus 111.1, then ln t from 400 to 1000. So we have ln of 1000 divided by 400, right? Because this will be ln 1000 minus ln 400, and if we simplify that, we have ln 1000 over 400. Okay, so now I think we can solve this using our calculator, no? Para mas mabilis na yung ating pagsosolve. Okay, so let's pull our calculator here. So first we have 1.507 times, okay, we have 1000, okay, minus 400, so we have 904.2, then minus 16.77 times 2 times the square root of 1000, then minus the square root of 400. Okay, so this is equal to 514.37, but still we have another term here, so we need to add that. So plus 111.1 times ln of 1000 divided by 400. So we have 616.17. Okay, so we have 616.17, and our unit here will be in kilojoules per kilogram. Okay, because our denominator in our CP, which is K, will be cancelled out dito sa ating dt here, no? So our temperature, it will be cancelled out in every term dito, no, sa ating equation. So this will be our final answer here. We got our delta H, which is 616.17 kilojoules per kilogram. Alright, so now let's go to our second problem. So in here, we have a gas having R of 320 joules per kilogram per Kelvin, and our specific heat capacity measured at constant volume. We have CV here, which is equal to 0.84 kilojoules per kilogram, no, per Kelvin. Okay, so our first requirement is to find the value of Cp and K. And next is, if we have 5 kg of this gas undergo a reversible non-flow constant pressure process from V1, which is equal to 1.133 cubic meters, and P1, which is equal to 690 kilopascal, to a state where T2 is equal to 555 degrees Celsius, find the delta U and delta H. No? So, ang kailangan nating makuha dito sa B is yung ating change in internal energy and the change in enthalpy given these conditions. Ano? So, first illustrate natin yung ating mga condition, ano, para hindi tayo malito. Okay, so we have our initial condition here going to our final condition. Ano? So, sulat muna natin yung mga given natin para mas madali. Okay, so first on this process, no, our R is equal to 320 joules per kilogram per Kelvin. Similarly, our CV is equal to 0.84 kilojoules per kilogram per Kelvin. Alright, so we have 5 kilogram of this gas. Okay, so we have 5 kilogram of this gas, no? And then, it undergo reversible non-flow constant pressure process. So our V1 is equal to 1.133 cubic meters, and our P1 is equal to 690 kilopascal. Now, it changes to a state where our temperature 2 is equal to 555 degrees Celsius. Okay? So, ang kailangan nating makuha, A, we need to find yung Cp and K, no? So, we need to find Cp and K. And then, at B, we need to find yung delta U and delta H. Okay? So, yan yung kailangan nating makuha dito sa ating problem. So, let us start with A, no? We need to find the Cp and K. Okay? So, let's have our solution here. Okay, so at A, we need to find Cp and K, no? So, we already learned sa ating lecture about specific heat capacity that there is a relationship between Cp and Cv, no? We know that Cp minus Cv is equal to R. Okay, so our universal gas constant. But in this case, our R is given and our Cv is given. Okay, so our R is equal to 320 and our Cv is equal to 0.84. Okay, so take note of our units. No, our Cv is expressed in kilojoules while our R is expressed on joules. So we need to convert that to kilojoule para mai-relate natin, ano. So, kailangan nating makuha is yung Cp. So, Cp is equal to R plus Cv, diba? So, now, our Cp is equal to R. So, ano yung ating R? Our R is 320 joules per kilogram Kelvin. So, we have 320 joules per kilogram Kelvin. So, let's convert this to kilojoules. So, we have 1,000 joules to 1 kilojoules. Okay, so plus our Cv. Our Cv is 0.84. Okay, so 0.84 kilojoules per kilogram Kelvin. No? So, as you can see here, our unit for joules will be cancelled out. No? But we can solve now for the value of Cp. Okay, so let us use our calculator again. So now we have here 320 divided by 1000. Then we have to add, okay, so plus 0.84. So we have 1.16, no? So we have 1.16 kilojoules per kilogram Kelvin, no? So, nakuha na natin yung value ng CP, which is one of the requirement. And ngayon, pinahanap sa atin yung K. So, we also learned it sa ating lecture about specific heat capacity, that K is actually equal to CP over CV, no? So, we just need to get this value here, no? Our CP is equal to 1.16 kilojoules per kilogram per Kelvin over our CV, which is 0.84, no? So, we have 0.84 kilojoules per kilogram Kelvin. So, as you can see, cancel lahat ng ating units dito, no? Kilojoules, kilogram, Kelvin, okay? So, we can get now the value of our K. So, our K is equal to, let's have our calculator. So, we have 1.16 divided by 0.84, okay? So, now we have 1.381, okay? So, we have 1.381. So, we got the value of our K. Okay, so now let us solve for the B. Kailangan nating makuha yung delta U and delta H. Okay, so B, we need to get the value of delta U and delta H. Okay, so we already learned this in our previous video about the basics of thermodynamics. Now, we know that our change in internal energy is equal to mCV dt, which is also T2 minus T1. And our change in enthalpy is equal to mCp T2 minus T1. Okay, so we have the value of CV and CP, no? We also have the value of our mass, which is 5 kilograms. Okay, ito. Now, what is missing dito, no? So, we have our temperature 2. Our temperature 2 is 555 degree Celsius. Pero, hindi natin alam yung ating temperature 1, which is kailangan natin dito, no? So, first, isulat natin, our temperature 2 is equal to 555 degree Celsius. Okay? But, we need to convert that to Kelvin. Kaya, small letter yung T natin dito because this is in degree Celsius, no? So, in many references, ginagamit natin capital T if we mean in Kelvin, okay? So, we need to convert this to Kelvin. So, we have 555, okay? So, 555 plus 273.15. We have 828.15. So, 828.15 Kelvin. Yan yung ating temperature 2. Okay? So, we don't know temperature 1 here, no? Let's write here. We don't know temperature 1 in our initial condition. But we could assume that we have an ideal gas in here. So, we could actually solve this by PBMRT. No, our ideal gas equation. So, we have PB is equal to MRT. Well, as you can see, no, ang ginamit natin is PVMRT, not the usual na nakikita natin, lalo na sa general chemistry, which is PV and RT, because Ender stands for the number of moles of gas, which is equal to the total mass of the gas divided by the molar mass of the gas, di ba? So, alam natin yon, our N is equal to mass over the molar mass, okay? Or our molecular weight ng ating gas. If we use that, our usual PV and RT will be PV, okay? Substituting this in our equation, yung nRT natin, so I will have MRT over M, right? Now, specifically dito sa case natin, kung makikita ninyo yung ating R dito, our R is expressed per weight or per mass ng ating gas, no? So, that is why, as you can see here, we have our molecular weight in here. So, we will have R over M. So, our R in here actually is R over m. Okay? Because it expressed per unit mass, di ba? So that is why ang may iwan sa atin dito, because we will have here a new r which is per mass ng ating gas. So we will have PB is equal to MRT. Okay? So that is why we will be using here PB is equal to MRT, which is the usual PB and RT, no, na alam natin sa general chemistry. Okay, so let me remove this to continue na sa ating problems, no? Alright, so ang hindi natin alam is yung temperature at condition 1. Pero yung ibang variables natin is given na, no? Yung ibang conditions natin dito sa ating state 1. So, since given naman sila lahat, so we can use that. So, this is initial pressure, initial volume, yung mass natin, R natin, in given, and di lang natin alam yung temperature 1. So, our temperature 1 is equal to P1 V1 over MR. So, ano ba yung ating P1? Our P1 is equal to 690 kilopascal, no? So, we have 690 kilopascal times our V1. So, our V1 is 1.133 cubic meter, okay? So, 1.133 cubic meters. And then, our M, our mass is 5 kilogram. Okay, and then our R. So, ano yung R natin? Given yan kanina dito. 320 joules per kilogram per Kelvin. So, I'm going to convert this na into kilojoules, no? So, we have 0.32 kilojoules per kilogram Kelvin. Okay? Alright, so we are not going through in our conversion dito, no? So you can work on that to prove that all of this will be cancelled out because kilopascal times the volume cubic meter is equal to kilojoules. So this will be cancelled out as well. So may iwan sa atin is our temperature in Kelvin. Okay? So that means we can solve for the value of our T1. Okay, so let us use again our calculator. So, we have, ito natin ilagay, 690, okay, times 1.133, okay, divided by 5, then divided by 0.32. So, we have 488.6, okay, so we have 488.6 Kelvin. Okay, so alam na natin yung value ng ating temperature 1. So therefore, we can now use this equation. We can get delta U, which is equal to mCv T2 minus T1. Okay, so our delta U is equal to mass, which is 5 kilogram, times our CV. So what's the value of our CV? Our CV is 0.84. Okay, so we have 0.84 kilojoules kilogram Kelvin. Okay, then times T2. Our T2 given na dito, 828.15. So, 828.15 minus our T1, which is 488.6, and this is in Kelvin, no? So, our units will be cancelled out. Kilograms and Kelvin. So, my iwan is in kilojoules. So, our delta U here will be equal to, so again, our calculator. So, we have 5 times 0.84 times 828.15 minus 488.6. So, this is equal to 1,426.11, ano? So we have 1,426.11 kilojoules, no? So this is our answer for our internal energy. Okay, so now we need to calculate for our delta H. So our delta H is equal to mCp T2 minus T1. Okay, so we know our M is equal to 5 kilogram. Our CP, na-calculate natin kanina, our CP is 1.16, ano? So we have 1.16 kilojoules per kilogram Kelvin. Then T2 is 828.15 minus 488.6, and this is in Kelvin. So now, as you can see, our units will be cancelled out. Ang may iwan is in kilojoules. So we can now solve for the value of delta H. So let's use our calculator again. So our delta H is equal to 5 times 1.16 times 828.15 minus 488.6. Okay, so our answer is 1969.39, okay? 1969.39. Tama ba? Let's say 1969.39 kilojoules. So this is our final answer in here. So let me box it. Okay, so we already solved for all the requirement. We got the value of delta H, delta U, our K, and our CP. Okay, so that's all for now. We solved 2 problems, okay, to show you how to calculate for delta H. No? So we will have a lot of lectures pa sa mga susunod pa nating mga videos for thermodynamics. So this will be all for now. Thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.